This is going to be the lecture over geometric proportions, the problems that are assigned here. What we're going to do is just go through these one by one, and I'm going to change the numbers just a little bit to give you an idea as to what it is that how these things work, and give you a chance to actually work through the problem and see what you can come up with. So let's take a look at the first one. Field size at 100 cm is going to be a 15 by 15. So what is the field size at 115? So let's take things, change them just a little bit. And rather than 15 by 15, we're going to change that to 16 by 16. So how does that end up changing? Well, we're going to use the argument here for similar triangles. So this angle here is going to be the same. So if we let things go to 100, say from here to here, that's going to be 100 cm. And then we've got a length here of x. How does that change when we go a little further to say 115? How does this length change? So that's what we're going to find out here. X plus delta x is how that's supposed to read. So let's take a look here. And if it's similar triangles, what we're going to find is that 16 at 100 is going to be equal to x at 115. So if we're looking for what it is at 115, we're going to be taking, basically multiplying both sides by 115 to get rid of it here in the denominator. So that and that cancel. So I'm left with 115 over 100 multiplied by 16. Punching that into the calculator. To call up a calculator here, that way you can kind of see exactly what it is I'm doing. So 16 times 5 divided by 100 turns out to be 18.4. Let me so that'd be the answer to the first problem. All right, so let's take a look at the second. Field size of 115 is 20 by 20. What is the field size at 90? I'm going to take that 90, I'm going to strike through it, and I'm just going to put it at 100. So what does this end up as? Well, as I had said before, we've got 20 at 115 is going to be equal to what at 100? So if I take x is equal to 100 divided by 115 times 20, so it should end up being a little bit shorter, which would make sense. So let's find out. 20 times 100 divided by 15, so 17.4. So there you go. Answers to the first two problems. Now, let's go down a little further. A tumor is 18 cm wide and lays 10 cm below the skin surface. If the treatment distance is 100 cm SSD, how wide should the beam be on the patient's skin to cover the tumor? So if it's 18 cm wide, let's change that to, let's change this so I can actually write with it. So let's go here, strike through that. So let's say it's 20 cm. Who sees a 20 cm wide tumor? I mean, I know what happens. Let's try. Let's go with 15. Still bad enough, but still. Okay. So if we're doing an SSD treatment and the tumor is 15 cm wide and it lays 10 cm below the skin surface, that means 15 at, if we're going to cover the entire thing, it's got to be 15 cm at 10 cm below the surface. So it's going to be 100 plus 10. So it's going to end up being 15 at 110. We don't know what it is at the skin surface, so we get to figure that one out. So X is equal to 100 over 110 times 15. So X is equal to what? So about 13.6. Okay. So that's for number 3. Let's go down and let's take a look here at number 4. Calculate the field size at 85 SSD if the field size at 80 cm SSD is 12 by 10. So let's change this. From 85 to 90. So what's the field size going to be? Well, let's see here. If we go to, let's see, field size, we'll start with the first one here. Let's see, 12 at 80. And what does that end up being at 90? Well, we're not exactly sure. So then X is equal to 90 divided by 80. I'm sure you can tell that's 90, right? You know what? Let's try this again. If we do the cross multiplication, we got 90 divided by 80 times 12. So the X is equal to 12 times 90 divided by 80. It's equal to 13.5. Does that make sense? And it should, because we're going from a length at 80, and then eventually we're going to end up with something that's longer there at 90. So that should be 13.5. cm. What about the other length? We had 1080. It's going to be equal to x at 90. Means x is going to end up being 90 divided by 80 times 10. X is going to be equal to, let's go to the calculator here. 11.25, so something around 11.3. Most field sizes, at least on the planning systems that we have now, I think I'd remember by now. Most planning systems by now will only let you go down to a 1/10 of a centimeter. So anyway, bear that in mind. So this, rather than 12 by 10 for a distance of 90, we would end up with 13.5 times 11.3. So let's scroll down a little bit. If we wish to treat an area of 40 by 40 on a unit that has a maximum field size of 32 by 32 at 80, what is the minimum SSD required? So in other words, we can't fit everything in at 80 source to surface. So what do we have to change that source to surface in order to be able to include all of that? In a case like this, you're not going to go, you certainly wouldn't go lower, because if you went lower, what would happen? You wouldn't be able to go from 32 to 32. It would be something less than 32. So obviously it's not going to be this. So the question is, which one of these others might it happen to be? So if we need to cover that particular requirement, how do we change this? And we know that we have we know we have 32 at 80. So the question is, at what SSD do we find 40? So let's see. If I take the x, multiply by both sides, x comes over here. If I get rid of this by multiplying by its reciprocal, both sides, that's what I'm going to end up with. To show all the math steps, we get to that. That ends up being x times 32 over 80 is equal to 40. But we want to get x isolated on one side by itself, so we multiply both sides by the reciprocal here. And so that's where that comes from. Now, multiplying that out, $80 divided by 32 multiplied by 40. So there we go. The new SSD used to be equal to 100 CM. Let me check here and see if I'm right, but I believe I am. All right, let's take a look here. There we go. Now, let's go down. A field size length of 22 cm at 100 SSD, or a field size length is 22 cm at 100 SSD. What will the field size length be? You know what? That's a question that really needs to be changed. I'm going to change it up so that we get a little extra practice here. So let's say 110. So if it's at 110, field size length 22 per 100 is equal to what at 110? That means X is equal to 110 divided by 100 times 22. X is going to end up equaling what? $24.2. Okay. All right. So clear a little bit out. Head down a little bit. All right, so suppose we have a maximum collimator setting of 35 by 35 available for treatment, and we need to treat with a field size of 25 by 50. If the SSD on this machine were 80 cm for a 35 by 35, at what distance would we have to treat? All right, so we need a maximum collimator setting at this, and we need to treat with a field size of this. If we're this, and then at what distance would we need to treat? Well, let's see. In order to be able, if we got a maximum collimator setting, so we broadened everything out, and we have to hit a field size with a field size of 25 by 50. The question is, how much more distance do we need to add in order to be able to get to cover this? Well, if we're looking at let's see, we have 35 at 80. At what SSD do we hit 50? So I move X over here, then the fraction comes over here. So I've got 50 times 80 divided by 35. So 114.2. Check cheat here and see if I've got that right. Ooh, look at that. All right. And I'm going to leave that at a point because I don't think you can go to the hundreds place as far as trying to find the SSDs in a lot of clinical rooms, or there's a lot of measure for error there if you try that. All right, so now let's scroll down a little bit. If a treatment beam is set at 100 SSD with a field size of 13 by 13 at the surface, what is the resulting field size at the surface if we extend the distance out to 110? For some reason here, we got a lot of people moving patients around to this, that, whatever else. Let's see. All right, so we got a field size of 13 at 100. So the question is, what's the resulting field size at 110? So we get X is equal to 110 over 100 times 13. What does that turn out to equal? So 13 times 110 divided by 100, 14.3. Okay. All right. Here's one that is, I know has thrown some people for a loop. And the directions here kind of need to spell this out a little bit more. So we've got a field here that measures 10 cm and 6.8 at isocenter. However, this picture represents a film at some distance from the source. So what is the source to film distance? And it requires a measure to requires a ruler to measure the actual size as shown. What you're going to need to do is to print this out. And then you're going to need to find a ruler in centimeters that measures from here to here. The film should actually be, I mean, the field size at isocenter should actually just measure 10 cm here. But when you print this out, it's going to measure at something different. You should come up, let's see, with a distance of about, let's see, 132.5 cm. And the reason is because that measurement over here, it goes from 10 to 132.5 C. Let's see, no, not 130. Yeah, just a second. There we go. Not 132.5, but the distance measure would be 13.25 cm. So you're going to go from 10 to 13.25. So you'll end up with, and this is measured at ISO. So if you've got 10 at 100, the actual measurement turns out to be 13.25 when you take it and you just measure from here over to here, which again, technically when you measure a field, it should go from one side over to the other. In this particular case, all we're going to do is we're going to go from here to here. So we're going to take that and it's going to become 13.25 times 110. So as it turns out, X becomes 132.5 cm. Magnification factor, this magnification factor is going to be the source to film distance divided by the source to surface distance, or in this case, the source to axis distance, which is 132.5 divided by 100. So it's 1.325. If we have to move the isocenter to point X, how much do we have to move? The question here, if we have to move it over here, again, that involves a measurement. That measurement should, boy, that thing's just bouncing around all over, should end up measuring about 1.06, which is what I'm going to write down here, or actually 1.4. that measurement up there from this point over to this point X, if you measure it using that same ruler, you should come up with 1.4 cm. So since you've got 1.4 at 132.5 equals what at 100? In this particular case, X turns out to be 1.4. Let's see if I can get this a little bit more. Over here. X turns out to be 1.4 times 100 over 132.5. And that is going to be equal to, all right, so 1.4 times 100 divided by 132.5. The answer here turns out to be 1.06. Okay. I hope some of this clarifies things for you, and let me know if you have any questions over anything.